Hello everyone, this is Kalpana working as an assistant professor in SNS College of Technology at the Department of Artificial Intelligence and Data Science. Today we are going to discuss about topological sorting in graph unit. Let's begin the session. This is our today's agenda. So first we are going to recap our previous session. Then we are going to see what is topological sorting and some real world examples of real world applications of topological sorting. So this is the recap of the previous session. So before that we have discussed about graph traversal. So we have two different traversal. One is breadth first search and another one is depth first traversal. So when we say breadth first, we scans level wise. That is first is 0 level and then 1, 2, 3 and then 4, 5, 6, 7. So like this level wise we scan, and for this breadth first search we use a data structure called Q data structure. And in depth first search we are not going to traverse level wise. So here first we are going to identify the source node. So we are going to find the adjacency of the source node. Source node adjacency is 1, 2, 3. So we are going to pick one first adjacent node, and then for that one adjacent node again we are going to search for the adjacent node of 1. So like depth wise traversal happens here. So for processing this depth first search we require a queue data structure. So both this breadth first search as well as depth first search is applicable for social media networking, and especially on Instagram and Facebook mutual friend suggestion, and for searching a friend we require these type of traversal. So with the help of these search, with the help of these traversal, we can achieve the mutual friend suggestion, and also visiting the friends network, and again visiting the friends network and getting the details of the friends, and all those things happens with the help of this graph traversal alone. And next we are going to discuss about this topological sorting. So before we are going into topological ordering or sorting, we must know the purpose of this topological sorting. So I'll first explain what is the purpose of this sorting. Just imagine a scenario, we are going to plan for an event. So whatever may be the event we are planning for, finally if you are going to make that event, starting from, we are going to identify the goal of the event, what is the aim of the event, what we are going to achieve it, and then we have to fix the scope of the event. Then we have to schedule it, which means we have to decide the date and as well as the venue where it is going to happen. And then the marketing, we have to market that event in order to acquire relevant participants. We have to do that and all those things. Okay, so these are all the list of things, list of steps we need to carry out, particularly to conduct an event, starting from the aim, scope, scheduling, and the planning, which means allocating the venues and deciding the dates and all those things. So these things are the steps to conduct a particular event. So just imagine just to make the event happen, we are following these steps. So these steps are dependent, which means first we are setting the goal of the event. From that goal, once we set, we decide the scope, and then comes our budgeting, and then our venue and all those scheduling things comes, then logistics and the event implementation. Okay, so one step is dependent on another step. Once we achieve the first step only, then we can go to the next step and next. So this is the order we follow. So like this, if you want to perform, if you want to make any order, like this, we need a sorting which is nothing but topological sorting in order to conduct things in order wise. Okay, so that is the main purpose of this topological ordering. So in order to make the things happen in order, we need a search which is nothing but, we need a sort which is nothing but topological sorting. Let's begin what is the definition and how we are going to implement it. So this is the definition of the topological sorting, as I told you. So we are, if you are going to have anything in a particular order, we are going to display anything in particular order, or we are going to make a, we are going to do a process in a particular order. So and for that cases, this topological sorting or ordering is very much important. And moreover, one more criteria is required for topological sorting is, it is if and only if the graph is a directed acyclic graph. It should be an acyclic graph. That means the graph should not have any loops or cycles in it. Okay, it should be a directed acyclic graph. That graph loop should not be there. Cycle should not be there. So you can differentiate with the help of this picture. Acyclic graph and cyclic graph. So this is a cyclic graph. Why we say cyclic? 0, 1, 2 and again 2 to 0. It forms a cycle. Okay. The source node is 0 and also ending node is 0. So it forms a cycle. It forms a loop. So this is our cyclic graph. Here the topological sorting is not possible with the cyclic graph. And here, and this is our acyclic graph. So when I say acyclic, obviously loop is not formed here. 0 to 1, 1 to 2, and there is no connection, there is no direction from 2 to 0. Okay, so this is an acyclic graph. Here cycle or loop is not formed. So topological sorting ordering is possible with acyclic graph and not with the cyclic graph. So that we must know before performing any topological sorting. It should be a directed acyclic graph. Okay. So with this we'll end this session, and in next session we'll see the steps and how we can perform the topological sorting for a graph. Thank you.